The economics of space exploration encompasses a diverse array of financial considerations, ranging from the costs of launching and maintaining missions to the potential revenue streams that can be generated from space-based activities. The economics of space exploration is not just about the substantial costs involved, it's also about the long-term potential for economic growth, technological advancements, and the creation of new markets. One of the primary cost factors in space exploration is the launch. For decades, the cost of sending payloads into space remained prohibitively high, limiting access to space to well-funded government space agencies. However, recent advancements in rocket technology, particularly reusable launch systems developed by companies like SpaceX, have significantly reduced these costs. The introduction of reusable rockets, which can land back on Earth and be flown again, is revolutionizing the economics of space exploration by making it more financially feasible to undertake more frequent and ambitious missions. Another significant cost in space exploration is the development and construction of spacecraft and satellites. These costs can vary greatly depending on the mission's complexity and objectives. For instance, robotic missions like rovers or orbiters are typically less expensive than manned missions. The International Space Station, ISS, one of the most expensive space projects ever undertaken, represents a significant investment in space infrastructure, with costs shared among the participating space agencies. The economic benefits of space exploration are numerous and diverse. Satellite technology, a direct result of space exploration, has become a cornerstone of the global economy. Satellites are crucial for telecommunications, weather forecasting, navigation, and Earth observation. The global satellite industry generates billions of dollars in revenue annually, providing services essential to numerous sectors, including agriculture, transportation, and defense. Space exploration also drives technological innovation. Many technologies developed for space missions have found applications on Earth, a process known as technology transfer. Examples include satellite-based GPS systems, advancements in materials science, and medical technology innovations. These spin-off technologies contribute to economic growth and quality of life improvements. The growing field of space tourism represents a new potential revenue stream in space economics. Companies like Blue Origin and Virgin Galactic are working on making space travel accessible to private citizens. While currently catering to a high-income clientele, the long-term vision is to make space tourism more affordable and mainstream, potentially opening up a significant new market. There is also economic potential in space mining. Asteroids and other celestial bodies are rich in valuable materials like metals and rare minerals. The possibility of mining these resources for use on Earth or in space-based construction presents an exciting frontier, albeit one with significant technical and legal challenges. The commercialization of low Earth orbit, LEO, is another aspect of space economics. Private companies are increasingly involved in space, conducting research, deploying satellites, and even planning commercial space stations. This shift from government-led to private sector-led space exploration is creating new economic dynamics and opportunities for innovation. Government investment in space exploration also has a broader economic impact. Space programs can stimulate economic growth by creating high-tech jobs, fostering new industries, and encouraging STEM education. The multiplier effect of government spending on space exploration can lead to increased economic activity in related sectors. However, the economics of space exploration is not without its challenges. Space missions are inherently risky, and failures can lead to significant financial losses. Additionally, the long-term nature of many space projects requires sustained funding, which can be challenging to secure, particularly in times of economic downturn or shifting political priorities. Another challenge is the regulatory and legal framework governing space activities. The Outer Space Treaty, which forms the basis of international space law, was established in the 1960s and may not adequately address the modern realities of space exploration, including commercial activities and space resource utilization. Developing a regulatory environment that supports economic growth while ensuring responsible and sustainable use of space is a key challenge for policymakers. Space exploration has historically been a field marked by both cooperation and rivalry. International partnerships, like the collaboration on the International Space Station, ISS, have led to cost-sharing and pooling of expertise, significantly benefiting the participating countries. Such collaborations can reduce individual costs, spread risks, and enhance the scientific and economic returns of space missions. However, competition, as seen in the space race between the United States and the Soviet Union, can also drive technological advancement and lead to significant investments in space technology. Emerging space economies, particularly in countries like India and China, are also reshaping the economics of space exploration. These countries are rapidly developing their space capabilities, offering launch services at competitive prices and investing in ambitious space missions. The entry of these new players is not only changing the dynamics of international space competition but also creating opportunities for new partnerships and global space endeavors. The role of small satellites, known as CubeSats and small sats, is another significant development in the economics of space exploration. These small, cost-effective satellites have opened up space access to smaller companies, universities, and even developing countries. They allow for a wide range of applications, including scientific research, Earth observation, and telecommunications, at a fraction of the cost of traditional large satellites. Moreover, the potential for in-orbit manufacturing and assembly represents a future shift in the economics of space exploration. Current space missions require spacecraft and satellites to be fully built and tested on Earth, a process that involves significant costs and limitations due to launch vehicle capacity and the harsh conditions of space. In-orbit manufacturing would enable the construction of larger structures in space, potentially reducing launch costs and opening new possibilities for space architecture and infrastructure. The growing concern over space sustainability and debris management also has economic implications. As the orbital space becomes increasingly crowded, ensuring the long-term sustainability of space activities is becoming crucial. This includes mitigating the creation of space debris and investing in debris removal technologies. The economic cost of not addressing the space debris issue could be substantial, including the potential loss of satellites and damage to space infrastructure. Space-based research and development, R&D, is a significant yet often overlooked component of the economics of space exploration. Space provides a unique environment for scientific experiments and technology development, including microgravity research, materials science, and biomedical studies. The knowledge gained from space R&D can lead to new products and services with commercial applications on Earth. The economic impact of space exploration also extends to education and workforce development. Space missions inspire interest in STEM fields and drive the development of a skilled workforce. Investment in space exploration can thus have long-term benefits for a nation's scientific capabilities and technological competitiveness. Finally, the future of space exploration economics might see the development of entirely new industries. Concepts like space-based solar power, which involves collecting solar energy in space and transmitting it back to Earth, could revolutionize energy production. While still in the conceptual stage, such ideas reflect the potential for space exploration to create novel economic opportunities. In summary, the economics of space exploration is a multifaceted and dynamic field, encompassing a range of activities from satellite deployment to deep space missions. It involves a delicate balance between costs, risks, and potential rewards, requiring careful management and strategic planning. The field is evolving rapidly, with new technologies, players, and business models emerging, promising to unlock new possibilities for economic growth and human progress in the final frontier.